Okay, so this video is teaching you how to use Python to run regressions. And I'm gonna focus on homework 6, question 3. Okay, so Python is very useful. I think I don't need to emphasize more. If you are going to pursue a life that is quantitative or a career that is quantitative or just anything else, okay, um, that Python is a useful tool, that it can not only handle a lot of data work, but also good at automating a lot of process that you want a machine to do it for you. Okay, so we will only learn how to run regressions. Okay, so Python can do 1,000 different things, and we're just learning a tiny fraction of it. But I think a good thing is you can learn by doing. Okay, um, you can learn you can learn how to run the regressions without any basic of Python or without any basic of programming languages. Okay, because I gave you the codes. Second, you learn from the codes about how Python as a language, okay, as machines to basically do things for you. Okay, what's the advantage of Python over Excel? First, the codes are replicatable. Okay, you can just copy these codes and run it as many times you want to without the needs to click all the things. Okay, and second, because it's replicatable, you can easily track what kind of mistakes you have made. But versus in an Excel, because you have clicked around things, you have moved around things, it's just difficult to check what kind of mistakes you made. Okay. All right. So let's get started. I want you to follow me step by step. So if you can use half of screen. And I will also post these codes on Blackboard. So you have all of these codes, or I'll give you this link. Okay, this link is online. You can open it and find the codes for homework 6, question 3. Let's get started. Okay, so we're using Python on Jupyter.org. Jupyter is a website that allows you to run Python codes online without downloading anything. Okay, we start from here. Okay, because our data so far is not large enough. Second, our codes are not large enough. Okay, we don't run thousands of lines of codes. Our codes is only 72 lines. Okay, all right, so let's get started. Once you open Jupyter.org, I'm probably gonna use half of a screen because I don't need that much of a screen, so that the other half you can follow me. Okay. Once I'm on this page, I scroll down. I click try in your browser. Okay. Okay. Sorry. I scroll down here. There's a Jupyter Lab, but I'm not gonna ask you to try Jupyter Lab first. I'm not gonna ask you to try Jupyter Notebook first. Okay, so scroll down and find the Jupyter Notebook. Okay, be careful, not Jupyter Lab, but Jupyter Notebook. And then click try it in your browser. Okay, so I'm using a Firefox, I believe. And what you can do is you can use a Chrome, or I think some of you use MacBook, it's fine. Okay, so here, once you are in this website called Jupyter.org, try, you come down and here is try classic notebook. You click here, okay? You're not trying Jupyter Lab, you're trying classic notebook. All right, so this fancy page comes out. Okay, and after about 10 seconds, here is where you get. Okay. All right, so next step, we are going to create our own notebook. Okay, what is the notebook? It's basically a page where you can ask Python to do something and Python can show you a result. Okay, so that's a notebook. Notebook is you can write down your codes and run. Run means you ask Python to do what your codes ask him to do. And then Python shows you the results. This is a notebook. Okay, notebook is the most common or most basic form of Jupyter. Okay, so where are you going? You're gonna click File, New Notebook, and then click Python 3. Okay, so here is a new notebook and it is untitled. You can click untitled and change its name. So I'm gonna change this name to Spring Semester 2021 Homework 6 Q3 because, oops, Homework 6 Q3 because this is the question 3 of Homework 6. I renamed it, okay. So here is a lot of things, simply ignore them, okay. Focus on the first cell, okay. This box here is a cell, okay. You can type anything here and then hit run cell, okay. And then you can hit run to ask Python 3 to run what you ask him to do. Okay, why is it Python 3, not Python? Because Python has changed. Its most recent version is Python 3. Okay. Are there people still using Python 2? Yes, but not many people are using Python 1 anymore. Okay, so what are you gonna do? You're coming back to this page or this file that I gave you. And you can see that all of these codes are organized as a block. Okay, so you're gonna copy paste. Okay, what you're gonna do is copy paste and learn at the same time. So you're copy pasting the first block, which is an exclamation point pip install linear models. Control, paste, and then run. Okay, so what this first step is doing, that this first cell is doing is install linear models. Okay, so Python himself or itself doesn't know how to run regressions, but some people have written packages for Python to learn how to run regressions. Okay, so we need to install linear models. All right, so a lot of these words comes out, they look complicated, it doesn't matter. After you paste, you will click this run right here. You can also use your keyboard, which is Shift plus Enter. Okay, Shift plus Enter. It's so your one of your finger press Shift and then hold it, and then another finger press Enter on your keyboard. I don't know what's the bottom, what's the buttons for a Mac version of laptop. So you figured it out, okay? If you don't know what it is, then you can click run. All right. So what I need you to do is to repeat, copy, paste, and run. Okay. So come back to this site, copy this block of codes, paste, and run. You can click run. If you use Windows, you can shift and enter. Okay. So yep, this is done. What does import means? Import means that, again, Python doesn't know how to do a lot of things, but people have written packages to teach Python how to do it. So we need to import NumPy, pandas, and stats model, because so stats model teach Python how to do statistics, regressions, f-test, t-test. Pandas teach Python how to handle a data set. Okay. So everything about handling data sets, including opening a data file, describe a data file, okay, add a new variable of the data file, or delete something in the data files, or combine two data files together. Everything are in pandas. Okay. Do not be so confused, because right now all you need to do is copy paste and run. But it is easy, or it is okay to be confused at the beginning that, oh, am I supposed to remember how to do all of these? And the answer is no, because you always start from someone else's codes and to modify it for something you need. Okay, so don't freak out if you don't understand. That's completely fine. It is a process of learning a new language. Okay, imagine you know English and you need to learn Chinese, and at the beginning it's gonna be difficult, and you probably want to learn how to speak, learn one word at a time. In Python, it's not the same. You just copy someone else's codes and modify it for your own purposes. And the process is understand what each line is doing. Okay. Okay, so you just need to know what they're doing. You don't need to remember how to write every line. Okay, you just need to understand. Okay, not even remembering, you just need to understand what they're doing. Okay, so NumPy teaches Python how to calculate. Okay, NumPy basically include a lot of mathematics. So Python knows how to plus, minus, times, divide, but Python doesn't know how to take natural log. Okay, so NumPy teaches Python how to do math. Pandas teaches Python how to handle a data file. Stats model, okay, teaches Python how to perform statistic models. So we have to import them as, okay. What does as mean? Why do we need to import as? So import NumPy as MP, import pandas as PD, import stats model as SM or SMF, basically are trying to find a shortcut, okay, or a shortcut for us to call those libraries or call those packages. Okay, because we're going to use some panda functions, or we're going to use some stats models. So it's easy for us to say SMF by telling Python that, okay, we need the stats model formula API to do some stats modeling. Okay, so if you type SMF later, Python will know that, okay, I need to find equation in stats models.formula.api package. Okay, all right. So this is importing. So next, copy paste and run. What is doing here? So first, this hashtag. Everything behind the hashtag, okay, on that exact line is a comment, okay? So behind the hashtag, Python would just say, oh, this is a comment. It's not something you asked me to do. It's just something for yourself to remember what you're doing here. And here is opening your CPS80 data file from Pearson's website. Okay, so what does this PD mean? This PD means that I'm telling Python that he needs to use pandas, or he needs to go into pandas to know how to deal with a data file. And here is opening a data file from this website. And I'm gonna name this data file 1, okay, or df1. So df1 looks like this, okay? It has 5 variables. We're familiar with it in our Excel, right? AHE, year, bachelor, female, and age. We have how many lines or how many rows? 7711 rows. Okay, remember why 7711? Remember in our Excel, it's 7712, but because the first line is variable names, so we end up having 7712 rows in Excel, but here in Python, you actually only have 7711 rows because the first row is already treated as variable names. So, and then you see here is only 77110. Why is that? Because Python regard the first observation as number 0. Okay, so if the first one is number 0, then the last one is 77110. Oh, sorry, 7710. Okay, but you have 7711 rows. Okay. All right. Next, copy paste run. This line is trying to take a look at the head, which is the first 5 observation of data file 1. Okay, what do you see here? You see 5 observations from 0 to 4. You see their average hourly earning, and you can see that there is only 5 variables, right? Okay, good. Oh, here. Next, copy paste run. What is it doing here? To estimate the constant term, again, this line is behind the hashtag. So this line is for myself to read, but Python will ignore this line because it's only a comment, okay? To estimate a constant term beta 0, or what we call intercept, we need to add a column of ones into our data set. Okay, so this is something weird about Python stat model. You need a constant column, okay? And in this column, everything is 1 to calculate beta 0. Is it strange? Yes, okay? Because in Stata or in Excel, this doesn't make sense. Why can't you just add it on your own? But that's the problem of the stats model. It doesn't matter. So I'm gonna add 1 column. Its name is const. Okay, or constant, but for my convenience, I call it const. And to my data file 1. And all of its value is 1. After I do this, I'm gonna take a look at the head again. Okay, what has changed? See, this is the head before, this is the head later. What has changed? Now I see a new column. Its variable name is const, and all of its value is 1. Okay. All right. All right, now we can finally run regressions. So copy, paste, and run. Okay, I'm gonna open this a little bit. Oops, because there is results. Can this results be bigger? Okay, good. Okay, I have to open this because there is results. Okay, so regression 1, I called it reg 1. What does this SM here do? This SM here reminds Python that now I'm going to use some statistic model. You have to go into the stats model package to learn how to run an OLS. Okay. Here's the endogenous variable, okay? Endogenous variable is the AHE in data file 1. What is endogenous variable means? It means the variable that we want to explain, okay? Which is average hourly earning. So what is exogenous variables? Exogenous variables are the variables that are used to explain it. So it's all the X variables, except that I need to put constant here. It's annoying, I know. Okay, don't forget to put a constant here because if you without a constant, you don't get beta 0, okay, which is wrong. All right, so the first line says to Python, go to stats model, learn how to run the OLS, and this in this OLS model, Y is AHE from data file 1, X are X are constant, age, female, and bachelor from data file 1. So the result 1 is reg.fit, reg1.fit, which means fit this model, and print out the result 1's summary for me. Okay, and then after you run it, this is the results. Okay, see, there's R square, adjusted R square. Okay, familiar. Dependent variable is AHE. What else? Oh, there's time and date. Okay, good. What else? What else? Okay, these things are important. Looks very familiar, right? Constant is, this is beta 0 hat, beta 1 hat, beta 2 hat, beta 3 hat. These are the standard errors. These are the t statistics for all of them. P-value, okay, all of them are significant. See, all of these t's are 0. What about this? 95% confidence interval, right? Everything is familiar. Okay, good. These things are not required. Okay, doesn't matter. All right. So in question 1, what does a person do? What happens to the average earning if a person increased by 1 year of age? This person earn $0.585 more if this person increased by one year of age, right? All right, next. Copy paste and run. Okay. What am I doing here? I am generating a new variable called log average hourly earning into the data file 1. How do I calculate it? So here I use NP because I need Python to go into NumPy to learn how to take a natural log. Okay. And I'm taking the natural log of the average hourly earning in data file 1. After doing this, if I look at the head again, I have a new column called log AHE. And it equals to log of average hourly earning. So copy paste and run. And this will be our second regression, right? What the second regression says. Everything's still the same, except that endogenous variable has changed into log AHE. Okay, so see that the only difference between regression 2 and regression 1 is I simply just changed this one. Okay, and oh, I also changed results to results 2, and I print out results 2's summary. Okay. What's the question? Let me see. 585. Next. Oh, second one is okay. Rerun the regression in part 1. Use the what's the effect of changing in age? All right. So log 55 to log 56. No. Oh, nothing. Okay. So one, because log is not on age but on AHE. So we know that this will be 100 times beta 1%. Okay, so that will be 2.73%. Right? Okay, next. Copy paste. Let me see. Where am I? Oh, yes. Next, taking log in the age, copy paste and run. You generate a new variable that is log age. And then continue to copy paste and run. You get regression number 3's results. What is here? You have now log age. Dependent variable is log AHE. Okay, so what happens? If you increase your age from 35 to 38, you kind of need to figure out how much percent is that first, right? So here is the code. You have to figure out log 36 to minus log 35. And then you times 0.8039, which is the coefficient. Now, because the dependent variable is in log, so it's 100 times that percent, which is 2.26%. Okay. All right. Next question. Rerun regression in part 1, but add a square of age. Okay. Keep going. Generate age square, copy paste, and run. Now, if you look at the head, there is a new variable called age square. And then keep copying, paste, and run. You get results for regression 4. Okay. Now, if I ask you expected AHE for a 40-year-old woman, okay, be careful which AHE you're using, okay? It's a log or not log. Now, it's not log, so copy, paste, and run. Okay, print out this. So this is beta 0. This is beta 1 times 40-year-old. This is beta 2 times 40-year-old square. This is beta 3 times 1 because female equals to 1. And this is beta 4 times bachelor equals to 1 because this is a woman with a college degree. So if you run that, you get that this 40-year-old woman with a college degree earns $26 per hour. Okay. Next. Next is asking you, oh, do we really need h square? Okay. Is h square significant? Nope, right? Because t statistic is small or p value is huge. Do we need these two combined? Okay. We cannot look at them directly. We need f statistics, right? So copy, paste, and run. Okay. So I'm gonna create something called regression, which is AHE on age, h square, female, and bachelor. I'm gonna create a hypothesis that is age and h squares coefficient both equals to 0. Okay. You don't need to remember how to write it. You just need to understand what's going on here. And then the results equals to using the package in SMF, run an OS regression that runs this regression using data file 1 and fit it. Okay, you don't really need to understand what fit means, but this is basically running this regression. And second, run an F test that your regression is from this result and your hypothesis is that 2 of the coefficients are 0. And then lastly, print out the test for me. Okay, so this is the result of the F test. Okay, what are the things you can see? The first thing is F statistics. F statistic is 130. Okay. Is that significant? What's the p-value? Oh, p-value is 1.279 times e to the power of minus 56. Okay, so this is, if you know what this means, you should probably know. Okay, this is scientific form or format of something that is nearly 0. So if p is almost 0, which means that this is significant, right? So we reject this hypothesis. If we reject that, then h and h squared combined has an effect. Okay. All right, so we reject h0. We reject it because F statistic is 130 and F statistic is significant. Okay, next. Copy, paste, and run. Now we have, what do we have? Now we have interaction term. Okay. See, I generate a new interaction term. And I run regression 5, copy, paste, and run. This is the results. Okay, here is the interaction term. Oh, it's significant. Okay, how do we interpret this? So female, so effect of age change with gender, right? So I allow the effect of age to change with gender. And so which gender has less effect from age? Female. Okay, so females' effect of age on log average hourly earning is 0.0168 smaller than men's effect of age. And because the dependent variable is log, we can interpret it as 100 times beta %. Okay, so that says women's effective age on earning is 1.68% less than men's effective age on earning. Okay, so that's how we interpret the effect of the interaction term. Okay, next. Copy, paste, and run. What we're doing here, very intuitive. Creating this new variable, which is an interaction term between age and bachelor. So now the last model, I allow, what do I allow? I allow the effective age on earning to differ across people with or without college degree. Copy, paste, and run. Here is, oh, it's significant again. So I don't think this is, let me see. Based on results in part 7, there is no statistical support. Okay. Oh, okay. So is there effective age on log hourly earning different for high school graduate than college? The answer is yes, because interaction term is significant, right? T is 4, P is 0. Okay. So yes. All right. Now, if you use this results and I ask you to calculate the log wage, okay, the wage in log, which is the dependent variable, or the predictive value for a 40-year-old woman with a bachelor degree, what are you gonna do? Again, copy, paste, and run. This is beta 0 for intercept, plus beta 1 times 40-year-old, plus beta 3 times 40-year-old times bachelor equals to 1, which is the interaction term. Okay, plus beta 4, which is minus 0.1844 times female equals to 1, because it's a 40-year-old woman. And lastly, bachelor, which is beta 5 times bachelor equals to 1. Okay. So it equals to 3.3. What does it mean? It means that I predict this woman's log wage is 3.3. Okay. So what if I ask you to calculate the predicted wage? Then you can calculate E to the power of 3.3, right? Okay. Let me see if Google knows how to do this. Oh, yes, which is $27. Okay. But in our homework, it only asks for its log, expected wage in logs. So it would be 3.3. Okay. All right, so that's everything about question 3 of homework 6. I think this is very good example of how to use Python to run regressions. And if you follow me step by steps, I don't think you would get stuck in the middle. Okay, so yeah, I hope if you already have some backgrounds of Python or other programming languages, good. If you prefer to use R, that's okay too. But if you have no backgrounds on everything, I think this could be your starts on just figuring out how Python do everything by just looking at this simple Jupyter notebook. Okay.